Hello students, I am Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is evaluating logarithms containing radicals or fractions as base or argument. We may have radical and fraction in a single logarithm, one as the base and the other as the argument, or the logarithm may contain either the radical sign as the base or the argument, or there may be a fraction. So we will be solving two questions in this session, and each of them will be containing either a radical sign or a fraction or both. Okay, so stay tuned till the end so that you know the process completely. And without any further delay, let us start with our today's session. And of course, this is a non-calculator session. It may be considered to be questions from paper 1 of IBDP. Okay? EE, of course. So, first of all, we come to the rules part. First rule says convert it to an equation by making the logarithm equal to a variable. So, there will be a logarithm given to us and we will be writing let that logarithm be equal to x, y, a, b, c, d, any variable. Okay. Rule number 2 says write the corresponding exponential equation and solve. Okay. So this is one of the methods of evaluating logarithms, and while I'll be explaining the questions, I'll be giving you another method of getting the value of the given logarithms. Okay. So let us start with our first question of this session. Question number 1, evaluate log of 5th root of 81 to the base 3. And as the first rule says, we have to equate it to some variable. I have equated it to x. So I have written let 5th root of 81 to the base 3 equal to x. And then we will be converting this to an exponential equation. It is 3 to the power of x will be equal to 5th root of 81. And I hope you know how to convert a logarithmic equation to its corresponding exponential form, or converting an exponential equation to its corresponding logarithmic form using the BPA rules. In case you are not familiar with this technique, I'll definitely be asking you to watch my previous videos on this topic. Okay? And now, since we have got an exponential equation, how do we solve exponential equations? The commonest method is making the base the same on both sides of the equal to sign and equating the powers. Or we may make the powers the same and equate the bases. But over here the power is containing x and we have to find the value of x, which is equal to the given logarithmic term. So we have to make the base equal to 3 for the right hand side, since the base is equal to 3 on the left hand side, so that we can equate the powers. And 81 is 3 to the power of 4. And since it is the 5th root written in exponential form, it will be 1 over 5. So it will be 3 to the power of 4 raised to the power of 1 over 5. And using the power law of exponents, it is a to the power of m whole raised to the power of n is equal to a to the power of m times n. So it will be 4 times 1 over 5, which will be equal to 4 over 5. That is 3 raised to the power of 4 over 5. Now we are having the same base, that is 3 on either side of the equal to sign, so we can equate the powers. X will be equal to 4 over 5, and the x is what? X is log of 5th root of 81 to the base 3. So this is equal to 4 over 5, or this can be written in decimal form, 0.8. This is not necessary. You may write this in decimal form. Of course, I have written this in decimal form because this is an exact decimal number. Do not ever convert a fraction to its corresponding decimal form if it is an approximate value. If if the question asks to give the answer in decimal format, then of course you have to give up to 3 significant figures. But otherwise, if you are asked to find the value of a logarithm and you are seeing it is 4, instead of 4 over 5, it is 4 over 3. If you want to convert 4 over 3 to to a decimal number, you will be getting 1.3 recurring. And you will not be giving 1.3 recurring. Of course, you will be writing 1.33, which is not correct. So don't give an approximate value. In that case, you keep it as 4 over 3. I have expressed this 4 over 5 as 0.8 because it is exactly, these two are exactly the same number. Okay. If the question says that give the approximate answer in decimals or up to 3 significant figures, of course you have to do the conversion. Otherwise not. Okay. So this is one of the ways. I have told you that I'll be explaining 2 ways of evaluating the logarithms. This is one of the ways. First of all, writing it as a logarithmic equation, then converting it to an exponential equation, making the base the same and equating the powers and getting the value of the given logarithm. This is one of the ways. And what is the second method? The second method is just write the argument in form of 3 to the power of 4 over 5. So this logarithm becomes log of 3 raised to the power of 4 over 5 to the base 3. And this power 4 over 5 can be brought down to the coefficient place, and it will be 4 over 5 times log of 3 to the base 3. Do you get me? In place of fifth root of 81, we are writing 3 raised to the power of 4 over 5. So the log term becomes log of 3 raised to the power of 4 over 5 to the base 3. And then we bring down this power to the coefficient place. It becomes 4 over 5 times log of 3 to the base 3. And we know log of a to the base a is always equal to 1. So log of 3 to the base 3 will be also equal to 1. So it will be 4 over 5 times 1, which will be equal to 4 over 5. Okay. So you can use any of these 2 ways. I have written this because I think this one is simpler for the beginners. But the second one that I have explained verbally is, of course, a shorter method. Okay. So once you are familiar with the evaluation of log terms, you can use the second method. Definitely. You will be needing lesser time. Okay. So now let us come to the question number 2. Evaluate log of 1 over 9 to the base square root of 3. In the previous question, in the first question, we had a radical sign in the argument position. Over here, it is in the base position and the argument is a fraction. Again, we will be doing the same thing. We will be writing a logarithmic equation. Let log of 1 over 9 to the base of square root of 3 be equal to x, and we will be converting this to its corresponding exponential equation. So it will be square root of 3 to the power of x raised to the power of x is equal to 1 over 9. And 1 over 9 can be written as 9 to the power of negative 1. Why should we be writing this? Because we have to make the base the same. We can keep the base as square root of 3, or we can make the base equal to 3 for both the sides. You can keep the base as square root of 3. I have made the base equal to 3 for both the sides. But if you want to keep the base as square root of 3, how do you write 9 as some power of square root of 3? 9 is 3 to the power of 2 and 3 is square root of 3 whole squared. So it is square root of 3 whole squared in place of 3, and it is 3 squared. So square root of 3 whole squared whole raised to the power of 2, or square root of 3 whole raised to the power of 4, and then there is another power, negative 1. You can have that. Square root of 3 raised to the power of negative 4. 4 times negative 1 will be negative 4. So you can have that. Square root of 3 raised to the power of negative 4, and this side is having square root of 3 raised to the power of x. So x will be equal to negative 4. But some students get scared with the square root, so I have made the base equal to 3 for both the sides. I have written the square root as 3 to the power of half. So it becomes 3 to the power of half whole raised to the power of x is equal to 3 to the power of 2 in place of 9 whole raised to the power of -1. And this is again using the power law of indices or exponents. It is 3 to the power of x over 2 is equal to 3 to the power of -2. Or x over 2 is equal to -2, that is x is equal to -4. And what is x? This log term. Log of 1 over 9 to the base of square root of 3 is equal to -4. Okay. This is one of the ways. Another way is again 1 over 9 can be written as 9 to the power of -1, which can be written as square root of 3 whole raised to the power of -4. -4 can be brought down to the coefficient place, and it will be log of square root of 3 to the base square root of 3, which will be equal to 1. So you will be having -4 times 1, which is equal to -4. Okay. Either way you come to -4. Whether you keep over here also I have changed the base to 3. You could have kept the base as square root of 3. This is base 3. You can have square root of 3 as the base. You can have a single log term and bring down the power and get the answer as -4. So there are so many ways. Once you understand the logarithm topic, you find so many ways of solving a single question, evaluating a single logarithm. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.